afternoon, ladies and gentlemen. It's a pleasure to be here and to talk about what we have been doing in our network and infrastructure. When we talk about network and infrastructure, it's inevitable to talk about IP. And if we talk about IP, this is a type of traffic that is massively flowing in today's telecommunication networks. In the last few years, there has been a dramatic shift in the way the customers connect. Back in 2007, when we launched IPTV service, we forecasted this move and have been upgrading our network across the entire chain. First graph shows that since 2006, traffic peak increased 25 times. IPTV traffic is in the network significant now, but only 1 year after its launch, and we're talking about 2007, IPTV surpassed the internet traffic, a tendency only reversed last year due to the explosion of video streaming in the internet. On the other hand, we know that despite this exponential increase, its volume significantly varies along the day, reaching its peak between 6 p.m. and midnight. This is due to both internet and IPTV traffic. We can also observe that the transport network usage during the peak hour is almost 7 times greater than in off-peak. This also shows that this industry has to start exploring some potential to monetize the network infrastructure by placing some traffic at off-peak. We are talking about approximately 40% of volume that is not used in our IP infrastructure. It's also curious to observe that the average monthly internet traffic consumption is different depending on access technologies. The average FTTH client consumes 62% more internet traffic than the average DSL client, meaning more value, better experience from its internet connection. At the bottom, we can also see that the average mobile broadband consumption is still low when compared to the previous, but, however, the take rate of smartphones and tablets will change dramatically this parting in the near future. There's a long list of factors when we talk about why did we deploy fiber, why in terms of an European nationwide operator, why did we do such an extensive and massive rollout of fiber that, as my CEO stated before, we covered 46% of the population. There's a long list of factors that sustain the decision for deploying fiber versus investing further in legacy copper. I will tell about 4 of them, deeply anchored to the Portuguese reality. The first one is everybody talks about civil works correctly being responsible for most of the capex. PT has a widely spread duct infrastructure with enough space available for new fiber cables. PT also fully owns its aerial infrastructure in pools. Within this environment, very little civil works were needed to deploy a nationwide FTTH network, representing less than 5% of the total rollout capex. Street cabinets. This industry is talking about VDSL2 technology with vectoring. And the biggest constraint in shortening copper loops with this technology is the amount of street cabinets needed. We are talking about shortening loops at 400 meters opposite to GPON FTTH with a 15 kilometers loop radius. This is an unrealistic scenario for Portugal, where street cabinets municipal licensing is hard to obtain or even forbidden in urban dense areas. Let me give you an example. In Lisbon, if I would like to roll out VDSL vectoring in my fiber footprint, I will have to put approximately 2,000 street cabinets. Mission impossible. Instead, I have 2 central offices with fiber to do that. My CEO also mentioned that one key differentiator that we have in our FTTH rollout, and this was key to compete against cable, was the possibility to put RF overlay, which is not possible in copper. Typical Portuguese has more than 3 televisions at home. It's not possible to carry RF overlay analog TV channels like competitor cable operators do. Therefore, not only XDSL technologies can truly compete with DOCSIS in terms of bandwidth, but they can also offer the same TV experience. Let me highlight that VDSL vectoring cannot do RF overlay also. So talking about cost structure, CapEx and OpEx. Deployment costs are usually referred as the biggest no-go to deploy an FTTH network. However, we are already experiencing, as later on my colleague Jason will tell you, that the fiber has a much more attractive OpEx structure than copper, minimizing operating costs up to 6 times. Moreover, fiber networks have less field interventions, meaning reduced maintenance OpEx. Sustainability and speed in terms of fiber. Fiber GPON-based services have a higher degree of sustainability, which is much less demanding in terms of energy consumption when compared with XDSL. Note that this represents important OpEx savings. XDSL solutions are much more demanding in terms of central office physical space, 4 to 6 times. I think we have to state also the importance of the physical space that the copper XDSL technologies occupy versus in the ducts versus the fiber. The fiber network is then future-proof, and its maximum bandwidth is only depending on PON and home networking technology in use. In GPON today, its maximum bandwidth is 1 gigabits per second, which is a value that's significantly greater than the maximum bandwidth in VDSL and higher quality of service. The thing that distinguishes the Portuguese consumer from others is the fact that they have massive technology, they are massive technology users. Knowing this, we would expect that the Portuguese citizen would far prefer fiber services. In fact, the take rate of fiber services versus copper is 22% higher in fiber zones, exactly for the same service. In terms of service faults, fiber clients have a better quality of service. As we all know, a fiber network is immune to some of typical issues in copper networks, such as humidity, attenuation, thunderstorms, or even theft. Year to date, the amount of service faults per client were 40% less in fiber networks, and my colleague also is going to talk about this. PT built a future-proof network. As we said before, our goal was to leapfrog copper evolution. Building a future-proof access network today, we are glad that that bold decision also recognized in 2011 when PT was distinguished by the FTTH Council with the Innovation Award on Deployment and Operations of FTTH network. Today, our GPON flows 2.5 gigabit per second passive optical network, fueling our 400 megabit per second demanding broadband service, as my CEO already stated. Today, the network is prepared in terms of equipment to go up to 1 gigabit per second, if we would like it. In the coming years, and without reinvestment, and this is very important, this future-proof network is prepared in terms of evolution for the next phase, and we think that the next phase is basically NGPON2. And NGPON2 not only will be able to cope with the wavelengths that we have today in GPON, we're talking about the wavelengths for RF overlay and the wavelengths that flow through the fiber for the IPTV existing GPON. This will enable us to fuel in exactly the same outside plant 40 gigabit downstream and 10 gigabit upstream. Talking a little bit about cable, which within Portugal reality, cable is the most aggressive competitor that we have in terms of triple play. Cable spectrum allocation is limited and shared by all cell customers. Upstream bandwidth is narrow and faces some serious limitations. For instance, the bandwidth from 5 to 20 megahertz is limited, or is of limited usefulness, and it suffers from man-made noise. This handicap worsens if we take in consideration that most of the coaxial cable footprints are more than 15 years old. Cable upstream handicap limits the provision of the services that require our bandwidth, such as interactive services. In general, cable spectrum limitations lead to a trade-off between speed per customer and customer per cell and TV channels. In summary, GPON downstream and upstream speeds are higher than cable. If we took the average bandwidth per customer at maximum cell occupation, the differences are relevant. GPON upstream is 6 megabits per second, while cable is only 500 kilobits per second typically. In conclusion, if you want to challenge an FTTH network, you need an FTTH network. And what we are observing, actually, when we talk about cable evolution and DOCSIS 3.1, what we are observing is that the business case in some cases don't fly. And most, even in Portugal, the cable operators are going for an FTTH approach. This was already mentioned, but PT has a comprehensive FTTH coverage. We cover already 1.6 million homes passed, 46% of the population, which represents approximately 74% GDP. Sorry. Talking about fixed fiber and radio 4G being complementary or being alternative, I think they are both. We think that in terms of complementary, for example, our GPON infrastructure already provides backhaul to all our mobile cell sites, for example, or the 1600 hotspots, Wi-Fi hotspots that we have already are being backhauled by our fiber infrastructure. But nevertheless, we can talk about alternative broadband accesses. I'll give you another example, and this is being shown in the smart city, that we can, with the 4G routers, we can basically provide broadband and voice services through IMS voice over IP. You can see that in the smart city. The rollout, when we do a rollout plan, everybody talks about network design, everybody talks about rolling out the fiber, but there is an extensive work that has to be done prior to that. And the work that we have to do is basically assume that within copper ADSL2 plus technology, providing IPTV services, the influence area of a central office goes to 2.5 kilometers maximum. If we're talking about fiber, I already mentioned that it has 15 kilometers. So immediately, a POP closure program was studied and approved. And in order to do that, we have to take in consideration from technical aspects to real estate values and also recurring costs, which means that basically in this program, we have a list of what we call fiber POPs. And this will be, in the long term, the POPs that we will maintain. We are talking about going from 1,900 POPs to 500 POPs, okay? So it's a huge savings that will, of course, be depending on also the regulatory actions in order to, for example, copper services to be decommissioned, okay? I'll give you two examples of the first two ones that you can see on the right side that we already are doing now in order to close these POPs in the long term. For example, all the IP fiber services, including enterprise, are only being provisioned in fiber central offices. The other thing is, for example, in Lisbon and all the big cities where we have FTTH, the same triple play service that was mentioned in the presentation before by our CEO, the client cannot have this, we don't provision anymore this service in copper. We only provision it in fiber. In summary, back in 2008, moving towards an FTTH network was the best way for PT to monetize every invested euro. 4 years later, fiber's network is leveraging in a cost-effective way multiple types of services and network backhaul applications, from connecting 40% of public schools to backhauling up to 92% of our cell sites. Sorry. Oops. Okay. Let's talk a little bit about mobile network evolution. And talking about mobile network evolution, this was already mentioned. There is a big momentum in mobile broadband worldwide with increase of traffic due to new services and new type of terminals like smartphones, data card, and tablets. I would like to highlight here that when we are talking about data usage, this type of equipment not only increase traffic in the network due to data, but also due to signaling, and we have been watching it very carefully, okay? Increased penetration of this type of terminals will be much more demanding from existing networks. This is what we call network-hungry equipments, okay? So they will consume a lot of bandwidth. And the other thing that we are observing is that the common way that you do the planning and optimization of your network is not depending on monitoring systems only anymore. You have to clearly, for each type of terminal and even for each type of brand, smartphone brand, you have to study and plan your network in order to give best quality of experience to our clients. 4G LTE is the most efficient data network. Yes, it is. I'm not going to, we're talking about latency, we're talking about speed, but I would like to give you an example, which is very simple. We are using, from last year's auction, 10 megahertz of 800 megabits, of 800 megahertz spectrum. And just in the rollout, just to give you an idea of the efficiency of the coverage per cell site, the influence area of a cell site of 800, it's 6 times higher than the one that we have in a common 3G cell site at 2100 megahertz. I like this slide. When we talk about 4G, the industry is always talking about speed. Industry is always talking about data. Even product guys are always talking about data, okay? But everybody has to talk about voice. And why do I want to talk about voice? Why does Portugal Telecom think this is key for us? It's very simple. Today, if we look at our network, most of the traffic, I can tell you 80% of the voice traffic is still being done at 2G, in the 2G network. And the 2G network uses a precious 101 gigabyte of spectrum, 1 gigahertz of spectrum, 900 megahertz band. In the long term, if we look at the exercise that we have been doing, and it's proved that basically each megahertz of spectrum of LTE can transport up to 14 times more voice clients than GSM. Then we are talking about cost efficiency. And then we are talking about why, in the long term, do we want to keep 2G? Because I have a precious 900 megahertz, high coverage, excellent indoor coverage band that in the long term I will have to use for LTE. And this is the way we are thinking about voice. So, of course, you can tell me that this will depend on the evolution and massive existence and usage of LTE type of devices. So we are talking about over 2015, probably, okay? On the right hand side, it's not new that the relative cost per bit, it can go up to 10 times lower from basically 3G to 4G at 2.6 gigahertz. This slide, I would like to, it's a complex slide. I'm not going into technicalities, but what I would like to stress here is last year's auction. In last year's auction, PT managed to guarantee maximum cap in all the bands that carry LTE, and we are talking about, as I spoke, 800, we are talking about 1800, and we are talking about 2600. So we are prepared for the next stage with aggregating speed through carrier aggregation with multiple bands. This is the million-dollar slide. How PT looks at the future in terms of mobile strategy. Voice, basically, has now extra spectrum in the 1800. So we bought spectrum at 1800. 1800 in Europe is used by big operators in urban dense areas when you need extra spectrum for GSM voice traffic. So what we are doing now in the short term for voice is putting this traffic, is putting more spectrum into this to increase quality of experience from voice clients at 2G. And when we talk about voice, I mentioned before, it's not easy to migrate voice traffic to LTE. So what we think is that over 2015, we will start massively migrating 2G and 3G voice traffic to LTE. So in, let's say, over 2020, we can start rationalize 2G and 3G. Rationalize 2G and 3G doesn't mean that we are going to massively spend CapEx on 3G in the next few years. What we have to guarantee for data, as an example, is to say we are only spending CapEx on 3G because we have the best coverage, the best national coverage, to guarantee quality of experience. We're talking about capacity. And how do you lower your CapEx on that is basically monitoring very closely where the traffic is coming from. Where are the hot areas, and cool it with Wi-Fi. Outdoor, indoor, we have to do it, okay? So, although we are talking about data, we mentioned that probably earlier than in voice, we are going to take out data traffic from 3G. It's because wireless broadband is happening faster than in smartphones. This was already mentioned by my CEO. Yes, by the end of this year, we will have more than 90% of the population covered with 4G. And this is sunk also for the strategy where we are using 2600 megahertz in urban dense areas, and out of there, urban, regional, rural, we are optimizing our CapEx and minimizing, as we will see in the next slides, the number of cell sites with 4G with 800 megahertz spectrum. More efficient network, yes. We are working on very hard to make it much more efficient in terms of mobile networking. I already mentioned we are minimizing signaling traffic, and this is not easy. We are actually, our clients will thank us because minimizing signaling traffic increase battery time on smartphones. We have done extensive work, operations and engineering last year, and we swapped all our 2G network for SDR type of equipment, meaning software-defined radio equipment, which actually was the base, is exactly the same equipment to this year's 4G rollout. As I've already mentioned, in 4G, I upgraded with 800 megahertz 66%. Well, if I would have done it basically with 3G, I would have upgraded much more sites. Equipment. We are already experiencing the energy recurring cost reduction. This equipment consumes approximately, this new generation 2G and 4G equipment, 30% than the previous one. Let's talk about network sharing. When we talk about network sharing, we are talking about OPEX savings, independently of being passionate about our competitors, okay? But there's money to be saved here. And today, 31% of our network is already shared with our competitors, which is probably up to, it's more than 15% savings that I have in OPEX when I'm talking about recurring costs like rental and electricity, so energy costs. We have been, since 1998, doing this in the Azores Islands, mostly tower sharing, but since 2008, we are working very closely with our competitors to do mostly infrastructure sharing, talking about towers and talking about containers. Some slides about evolution. Probably most of you already have heard this. We are watching very closely the evolution of LTE Advanced. According to what we are sensing from the industry, today our CEO already mentioned that we can do 150 megabits. We think that in 2014, with carrier aggregation up to 20 megahertz, we will be able to do 300 megabits per second. Long term, we are talking about 3 gigabits per second downstream and 1 gigabit per second, 1.5 gigabit per second upstream. The increased demand for mobile networks data capacity in coastal areas and multi-dwelling urban zones, new topologies, need to focus on capacity enhancement. When we talk about heterogeneous networks, we are not talking about only improving quality of experience of our clients, which is very important. We are talking about maximizing every euro spent in the spectrum we have. So massive adoption of data in smartphones and tablets, we will have to come to this because spectrum is not infinite. The other thing that we are addressing basically is self-organizing networks. When we talk about self-organizing networks today, all the planning on optimization and configuration of mobile networks are done manually. And of course, even if it is done like we do it in excellent terms, we have to think about automating the automation of all this. So we are also monitoring very closely what is happening in this industry, what we call self-organizing networks, in order to be able to configure and to plan and optimize our mobile network. So we are well prepared for the future. We have 92%, as already mentioned, sites connected with fiber. We have 100% of 4G LTE sites with IP Ethernet backhaul. We have best national coverage according to the National Regulatory Authority. We have more than 90% of population. We have IMS-powered advanced services like Rich Communication Suite and VoLTE. Let me talk a little bit about VoLTE. Actually, as we speak, is being issued a press release that Portugal Telecom, I have a pleasure to announce you that Portugal Telecom, in its operational network, so production network, we did the first tests of VoLTE and it worked. So this is one of the first networks in the world to be VoLTE compatible. So let me explain what VoLTE is. It's simple. Today, when you make a phone call from a 4G smartphone, you have what, it's a buzzword, like a technical circuit switch fallback, which means that you have to go down to 3G or 2G and make your phone call. And then you go up to 4G again. And this is how all industry is doing. So VoLTE is the true voice over IP that it will be much more efficient. VoLTE is the key to do what I previously told you, that is migrating and taking in the long term, all the voice traffic out of 2G and 3G and put it in 4G. We can already do it. So we are hoping that our vendors will massively come with this type of terminals with VoLTE. We are expecting that. Last piece, we are talking about mobile network integration. PT is the only nationwide operator with true convergence. You cannot own only one mobile network or have fixed network, so we have all the pieces of the puzzle. But the most important thing, and my CEO already mentioned that, is to have common platforms, to have unified network planning and unified operations. That today is one single organization that is doing this type of activities. So we are basically pursuing seamless service delivery across network optimization paradigm, taking into account user traffic profile, network data mining, coverage, and geographic location. This all-IP backbone, when we talk about convergence and an all-IP backbone, Wi-Fi is key to make this step in terms of convergence. And when we talk about Wi-Fi, we are already in the 1,600 hotspots that we are doing several key things. Now and in the future, we hope to do. For example, seamless subscriber authentication. All of our clients today, Portugal Telecom clients already, when they go into a Wi-Fi zone, the smartphone automatically, through the SIM card, authenticates the user. I can tell you that the last indicators, more than 50% of our clients, of the authentications within our Wi-Fi network is already being done with eApp-SIM. Okay? Some of them is not even voluntary, because you go to a coffee shop or you go to a commercial center, you go there and you automatically, your mails start flowing in the smartphone through the Wi-Fi eApp-SIM. The other thing is basically the automatic 3G, 4G LTE offload to Wi-Fi in hotspots that we are already doing. Seamless handover between hotspots. This is something that technically we are finishing, and it's not possible today. If you go to a Wi-Fi zone between hotspots, you lose session. You have to start again. If you're looking at the video will stop, basically. And we think that through this modernization of Wi-Fi, it will enhance customer mobility, but also increases satisfaction, loyalty, and cost efficiency for us, of course. It's a brief slide talking about the programs that we are fulfilling at the same time. We are upgrading, as we speak, all our 1,600 hotspots to fiber, most of them with GPON that we have been talking about. We have, and you can see in the smart city also, the development that we did to put our phone booths with Wi-Fi for outdoor coverage. As I told you before, the outdoor coverage will be done in hot areas. We are working on a Wi-Fi residential community that my CEO already mentioned, and this is a specific residential community that will also guarantee quality of experience and handover between hotspots. It's key. I will talk a little bit about monetizing the network investment. So, when we talk about monetizing network investment, we talk about how we should maximize the use of the fiber. I think this was already been mentioned in the previous presentation. I already mentioned also to explore the unused capacity. I told you that today volume, 40% of the volume in off-peak is not used in the network, so we have to be, for example, machine to machine. When we're talking about low priority traffic with machine to machine, we can do like electric companies. We can provide our clients the ability to put machine to machine at off-peak hours at a lower cost. Of course, technology evolution and embrace fixed and mobile convergence like fixed services over 4G LTE that you will see also in the smart city. Last slide. So PT has built a convergent state-of-the-art access network with FTTH, 4G, LTE, and Wi-Fi. We, also mentioned by my CEO, have a high-capacity transport network with 100 gigabit per second. You can ask me 100 gigabit per second, what is this? This is, for example, equivalent to transporting 0.12% of all global internet traffic in one single link. So today, all our international connectivity to the internet, gateways, and the main backbone nodes are connected through 100 gigabit per second speeds. We are talking about a capex reduction per bit of 20%. So the last piece of this puzzle is the data center, basically. And it has been a pleasure to work for this presentation. And as seeing is believing, tomorrow you can see some of our not only network FTTH and 4G features, but also the products from our product guys. I will leave the floor now to Salas Pires, who is responsible for the data center project. Thank you very much.